For lesson number 4, what is a function? Now, so far in the chapter, we've been talking about relation. We've been talking about linear, nonlinear. We've been talking about straight line, curve, points, individual points, continuous graph, discrete functions, or discrete data set. So here is just one extra term that we are going to learn in this unit. So what is a function? And how does it different from relation? How does it different from what we have learned in the past few classes? Now, in fact, when we are talking about a function, it is a special type of relation. It is still a relationship between two variables, whether it would be x and y together, like a random equation y equals 2x, or y equals x minus 1. This is a relation, and when it comes to a function, this particular equation will give us a very, very special property. You are going to get only one answer for every input that you are using. So what does it really mean? Now let me give you an example that will give us more than one answer when you use the same input. Now it doesn't have to be an equation, it could be just be a sentence. I can say the time you need to go up the gross mountain. How long does it take? How long does it take you? It really depends on whether you do it in the morning, in the afternoon, or in the evening. When you decide to go up the gross mountain in the morning, you probably will finish it in approximately a minute?
Yeah. Half an hour.
Half an hour? Well, you will go up in a minute if you try to use your finger and move your finger up on the map. That would take you 1 minute to go up the gross mountain. But technically, a regular person would take approximately an hour. Yes, you go hiking, right? I'm not asking you to take the gondola, right? Yeah, a very fast person, a capable person would probably finish it in approximately 30 to 45 minutes. Very fast. Yeah, that's fast. But usually, if you don't have regular training, you will take an hour to finish it. But if you do it in the afternoon, when it is really hot, during daytime, you probably will take longer to finish the hiking up the mountain. And what about in the evening? If it is completely dark, you probably will have a tough time going up the gross mountain anyways. So it really depends on what time you are going up. But you're talking about going up the gross mountain. So with the same input, with the same thing in mind, you will end up with different outcome. It depends on what time you go hiking. You are not getting a unique output. Right? You're not getting a unique output in this case. A unique output would be something like, once you do it this way, you are going to get the same result all the time, such as solving an equation. When you are working with an equation like 2x, if I use x equals 5, my answer will always be 10. You get the same answer all the time when you are using the same input. If I use x equals 5, put it into this equation, I'll be getting the same answer whether I do it in the morning, tomorrow, or yesterday. So that will be a unique output for your input. There are times that you don't. And I show you that example, the gross mountain example. So in order for something, a relation, to be a function, you want to obtain the same output every time when you are using the same input. So how do we tell whether a given relation is a function or not? Like if I put it in a sentence, it will be very difficult to figure out whether it is a function or not. Like the example that I show you with the gross mountain. Like if it is in a sentence, it is difficult to figure out. But if you put everything on the graph, it will be very easy to see right away. All you need to do is to use a vertical line and move your vertical line across the graph from the left hand side to the right hand side. So let's say in this case, let me draw a vertical line, and as I move this line from the left to the right, at every point we will only get 1 point on your graph, and that means you are getting 1 output every time. This is what we call a function. Ben? Yeah? But if you end up having this vertical line hitting your graph at 2 points.
Yes, you're getting 2 points and then 1 straight line.
Yep. That will just be a relation and not a function. If you have this vertical line hitting your graph at 2 points or more, that would not be a function anymore. It doesn't matter if you have 1 point there. If there is anywhere on this graph that will give us 2 points or more, if this vertical line would hit your graph at more than 1 point, this is not a function. So this is not a function, and this is. So having your relation graph on the grid would help us identify whether it is a function or not. But there are times when a relation may be given in terms of something else. Instead of having a graph, you may have a couple of points given, or you may have a table of value given to you. If it is difficult for you to identify whether it is a function or not, graph it out. Plot your points on your graph and see if it passed your vertical line test. And graphing shouldn't be that difficult. It should only take you at most a few minutes, but it will help you to identify whether a given relation is a function or not. So here in this case, we are starting with -3 and +2. That's the first point, -3 and +2. And then we have -1, +1, 0 and -1, 1 and -1, 2 and 3, and then 2 and 5. When I bring this vertical line from the above and put it on my graph, well, I have no problem at this point. But as you move this vertical line across, what happened? Do you end up with 2 points that would touch this vertical line? Yeah. That would be problematic. And that means this is not a function. Anytime when you see a vertical line hitting your graph, hitting points at 2 different places or more, that is not a function. So as you can see, if you just look at the order pairs, if you look at the question only, you probably will have trouble telling whether it is a function or not. But once you draw it out, things will be pretty easy to see. So if you ever have trouble with this, graph your relation. Draw it out and use the vertical line test to answer your questions. So here for the next one, I'm going to do the same thing. I'll create a graph with points given to us. And yeah. So for this one, -5, -2, plot the point here, and then -3, +1, 0, 0, 3 and 1, 5 and 3. Moving by creating a vertical line. Let's say this is my vertical line, and let me put this vertical line on top of my graph. Having this vertical line move across it does not create 2 points or more. Every time at most you are getting 1 intersection only. And what does it mean? Is it a function? Yes, it is a function. Now, once you're more familiar with this concept, you can then start to look for the same result when you are using the same input. If you are working with the same input, you would expect the same answer. But in this case, if they don't, when you look at this example here, when you are using the same input and the relation end up with different answer, that will not be a function anymore. For your graph to be a function, the same answer will always give us the same input will give us the same answer. Different number, no problem. It doesn't matter if your answers will be the same or different, because when you draw it out on the vertical line test, they will have no problem to us. But if you have the same input, you expect the same output.